So, summations question. So here it's telling us to use these formulae to show this. So this is not, some people get confused with the proof by induction. It's not, it doesn't say that anywhere. We're just going to use the formulae. Now these are from your formula book. So we're starting with the sum from r equals 1 to n, r squared times 4r minus 3. So the first thing you might want to do is expand r squared times 4r minus 3. And the other thing we need to do is split this summation up so that we can use the formulae, because we know we're allowed to do that. So that's going to be 4r cubed subtract 3r squared, and I've just left a gap because I'm going to put the multiplier in front of the summation. Then you can go to your formula book. I'm leaving off the sum from r to 1 to n here, but remember that's what every summation sign means. So that's going to be 4 times a quarter n squared n plus 1 squared minus 3 times a sixth n plus 1 to n plus 1, taking it straight from the formula book. It's worth not doing too much in one go, just literally copy the formulae out first. Then we can think about doing some tidying up. It's the best way to do this is to factorize as soon as you can. Take out whatever factors you can. So I can see I've got n and an n plus 1. So I'm going to take those out. I'm going to sort the numbers out. So n plus 1. Right, 4 times a quarter, so that's going to go. That's going to leave me with n plus 1 there. 3 times a sixth is going to be a half. And n plus 1 goes, so I'm left with 2n plus 1. Let's have a look at where we are going to. It says k is a constant. So we will work k out later, so we're not quite sure what it's going to be. Well, let's have a look. If I multiply out this bracket, I'm going to end up with plus a half there. So you have two choices. You could expand all the brackets now, or you could now take a half out as the factor. If you take out a half, that means this first term needs to be multiplied by 2, so that 2 times a half is 1, so we get 1 there. Then that's going to be minus 2n minus 1. Then I'm going to expand the brackets. Okay, you can see the plus 2n minus 2n is going to cancel. So that's as simple as I can get that. Then I'm going to check what were we showing and does it match. As you can see, those two things match. K is a half. So I have shown. What do they want us to do now? There we go. Oh, maybe not, because I forgot the second part of the question there, so it's not zoom in. Now they want us to hence evaluate this. Now, because it's a hence, we need to use what we've just shown. So you can't just put this in your calculator. You can put it in your calculator to check, and it might be able to cope with it and work it out for you, but we do need to show some working. So what are we going to do? Well, that sum from 20 to 40, we need to split that up because our formulae starts at 1. Okay? So what we can do is we can add up all the terms from 1 to 40, and then we can take off all the ones we don't want. So we won't want the first 19 terms of that sequence. It's always one less than the bottom number. So we're going to take off the first 19. Then we need to use our formula. So our formula said whatever n you're going up to, that's what's in our formula. So that's put 40 into the formula. Oh, it should be a half, not a quarter. N plus 1 is going to be 41, and then 2 times 40 squared minus 1. And then we're going to subtract the formula, but with 19 in it. And you're going to work all that out you might want to show an intermediate step, but you should get 2486190. As I said, check in your calculator, but you have to show you've used the formula. Okay, so you're going to need some working. Okay, right, so that was the first part. So the second part was similar, and then with a sort of a little bit harder section right at the end there. Okay, so the first bit is we're using the formulae again to show that here. So starts off the same. We need to change this sum into the sum from 1 to n of r cubed minus 3 times the sum from 1 to n of r. It says relevant formulae because we're not actually going to need the r squared formulae here because there is no r squareds in our formulae. So then we go to the formula book, so we just use the r cubed formulae. Now the sum of r, it's supposed to be an r, is not in your formula, but you have to remember this. It's a half n plus 1. Oops, so that's 3 over 2 times n plus 1. Again, let's have a look. So is there any factorize I can do straight away? Yeah, look, n and n plus 1. Okay, so we're going to take that out straight away. If you have a look at the answer, we want an n over 4 at the front, so we want to take out a factor of a quarter. Now, if I take a quarter out, in order to get 3 over 2, I'm going to need to change that to 6, because 6 times a quarter is 3 over 2. So 6 times a quarter will give me the 3 over 2. And then I'll just expand all that out. Okay, if you have a look, we've got to factorise that some more. You can always use your calculator to help you, but we can see from where we're going, this must factorise, so that's n. It's going to be 2 and 3 to get the 6. It's going to be subtract 2 plus 3 to get the n in the middle. And I'll just check, and that is the form that they want. Always probably worth, actually, when you get there, writing something like as required, QED, something like that. Should have done that on the earlier one as well. Right, the second part of this was quite tricky and very few people actually got this one. So now we're doing a series. Now the best way with this is to see that there are 2 different series going on here. There's the odd squares and the even squares. So if we just look at this, we're doing 1 squared plus 3 squared plus 5 squared plus, and the last odd number we're going to add is going to be 2n minus 1 squared, and then we're going to take off the sum of the squares of the even numbers, and that's going to go up to 2n squared. Okay, so now we can write a formula for both of these parts. So this is the sum from r equals 1 to n of 2r minus 1 squared, so the last bit of our formula there. And the green one is the sum from 1 to n of 2r squared, as you can see. So there's our final term. That shows us the pattern. Right, so once I've done that, it's actually easiest to simplify that before you apply some formulae. So now we're kind of thinking backwards. Instead of expanding it, we want to rewrite it as one sum. So that's 2r minus 1 squared minus 2r squared. So that's the sum from 1 to n. I'm just expanding the brackets there. And you can see the 4r squareds are going to cancel out. and we get down to the sum from 1 to n of negative 4r plus 1. So then we can put that into a formulae, so that's negative 4 times the sum of r plus, so because we're splitting this into negative 4, the sum of r plus sum of 1. Now if you sum up 1 from 1 to n, that's n. So then we can simplify this. So that's going to be negative 2n squared. It's going to cancel out. Take away 2n plus n, which is going to be negative 2n squared subtract n, which you can then factorise. We want to factorise out into the form they want. So I'm going to take out negative n. That's going to leave me with 2n plus 1. So that's the form that they required. There are a couple of other ways to do that, one of which is in the mark scheme. At least one person looked at the sequence and thought about the differences between the terms and managed to get to the same summation formula as well.